BGP route reflector is a major component of BGP design, and yesterday in the video I did some configuration in which I explained the rules, the basic rules of operation of BGP. So we learned that if anything is learned over iBGP, will not by default be sent to other iBGP peers unless it is received on the route reflector, and then route reflector actually passes this information on, breaking this rule. So let's look at all those rules now in more detail. So in my example, the R1, let's say, imagine R1 and R5 are BGP route reflector clients, and R2 is a route reflector. We call this a cluster or route reflector cluster. So cluster is basically route reflector and its clients. So R2 is a route reflector. So whatever we learn over eBGP, let's just look at the rules. So here's my rules. If I'm a classic router, if I learn something over eBGP, I'll send it to all peers, iBGP peers and eBGP peers. So like in this example, let's say if R1 is non-client, it's just a regular classic router, whatever it receives over eBGP, it would pass this to either iBGP clients here, and if it had eBGP connection, it would pass this prefix also to AS30. That's a classic router. If the classic router receives something over iBGP peering, it can only send it across to eBGP peers. So that was exactly my problem yesterday. If R2 was not a route reflector, everything learned over iBGP would be sent only to eBGP peers, but not iBGP peers. As a result, R5 would never know those prefixes advertised originally by AS100. So I changed that and I created R2 to be a route reflector. So let's go back here to the table. So now I'm a R2, I'm a route reflector. If I learn something over eBGP peer, I send it to everyone, iBGP and eBGP. If I receive something from non-client, and let's say in my case, for the argument's sake, R1 is non-client, so only R5 is a client, whenever I receive something over iBGP and I am a route reflector, I will send it across to all eBGP peers and my clients. So this was the situation yesterday. R2 received prefix from R1, originally advertised by AS100, and to be a route reflector, I need to make sure that I have some clients to pass this on to. So whatever is learned over iBGP is advertised to eBGP peers and its clients, if there are any. And R5 was my client yesterday. If I receive something from the client iBGP peer, I will send it to all peers but the sender. So again, let's imagine the situation that R2 is a route reflector, and let's say R1, R4, and R5 are its clients. If that's the case, what I'm going to be receiving from the client over iBGP, I'll send it to other clients, but the one that sent the information towards me. Also, I will send it to all eBGP peers. Let's see what happens when a client receives BGP advertisement. So the client can get it from two sources, like in this table. In the previous video, we talked about this a little bit. So when the client is receiving from prefix from the eBGP peer, it advertises them to everyone it is peering with. Simple as that. But if the client is receiving the prefix over iBGP peer, it can send them only to eBGP peers to avoid the loop. But it gets something as well. So let's look at the prefixes. In the previous video, we advertise. In the previous video, we advertise those prefixes. So I'm receiving some prefixes on R1 over eBGP, and R1 sends them to all eBGP peers, there aren't any, and all iBGP peers, and there's only one. So R2 is receiving now prefix from a R1, and then it doesn't matter if this is a client or not, but if R2 has a client R5, so this route reflector is going to reflect that prefix or those prefixes back to its client. So it's breaking the rule, don't send anything learned over IBGP to another IBGP. We can, because R5 is our client. So what we receive is 4 prefixes. Let's just take a look at them on R5. Show IP BGP. We are receiving those 4 prefixes from our route reflector. So let's take a closer look at one of them. Show IP BGP 100.10.0.0. What we received, apart from the prefix, next hop address, and so on and so forth, and a bunch of attributes we didn't discuss yet, we receive an attribute that is called originator, which points to the device router ID who originated the prefix. And we also have a cluster list. And cluster list says, this is my route reflector. I have only one. It's 2.2.2.2. That's my peer R2. Now, why is it so important to receive that? Cluster list is particularly important here because it will be a loop prevention mechanism. So let's imagine the following situation. That we somehow receive the prefix, we send it across, let's say over here, maybe R1 is also route reflector, and it's sent back to R2, the one that originated that prefix. So whenever the route reflector is advertising prefix, it is prepending its own name here in a cluster list. So when the traffic or prefix comes back to me in the loop, it will say, oh, hang on a second, I was the one that already sent that prefix. I'm receiving. I see myself in the cluster list. I will ignore that update. So those 2 optional non-transitive attributes are always attached to a prefix that is advertised by the route reflector to avoid loops in the system. As for the rest of the attributes, we'll start slowly looking at those attributes because they are playing a major role in a route selection path for all BGP prefixes.